Hello and welcome to chapter 3. Now you must be wondering that we are trying to undertake software engineering and we haven't yet written a program. There is a reason. While we study how to cut good code by learning the syntax of Java or Python or any other programming language, what we are studying here is being able to design something that will be of value to the user, that will be of value to the business. So we are trying to clarify our understanding of what is a good quality code, how it can be reused, how it can be maintained with ease, how others who have to look after the code that you and I have written would find it easier to maintain. So in this chapter we are focusing our attention on the fundamentals of object orientation. Now I don't consider object orientation as something very specific and therefore something that is against any other mechanism of creating good design or good architecture. The concepts, the fundamentals are so good and so universal that you can apply them in almost every programming, in every software related work. So until now we studied or got a taste of the various UML diagrams, 14 of them. We also clarified in our mind of minds what is an object, what is a class. We also realized that UML is like a toolbox. There are 14 diagrams. You don't have to use all 14 when you do your design work. There are some diagrams that are of value in the problem space, and with the help of those diagrams we create a model of the problem space. This is typically requirements engineering, business analysis. Then there are some diagrams that are of great importance in the solution space. So with their help we create a model of the solution space. And then diagrams like component diagram and deployment diagram and their variation provide us a modeling construct in the background space, architectural space, and project management space. So here with this knowledge we are trying to understand the 5 core fundamentals of object orientation. Each of them is going to lead us to good software engineering. So what are those 5? We have classification, abstraction, inheritance, encapsulation, and polymorphism. And in the chapter you will find description and examples of each of these 5 fundamentals. Of course I have used very generic, very simple examples to clarify the concepts. Classification, you look at a reality, you look at the business for which you are trying to produce a software solution. It's made up of many objects, real objects, your account and my account, you as a customer, I as a customer, or a hat or a cat or a flower, numerous objects. So the first thing you will do as a good software engineer, as a good program designer, is classify them. Okay, a hat and a flower pot can go together as things, and a cat and a man go together as living beings. Now this classification that I have given as an example, you apply in a banking, in an airline, in a hospital, in travel domain, whichever domain. Then we have abstraction. Excuse me. So we abstract from the bits that we have classified higher level entities. So we could be abstracting from objects to classes, and then from classes to further abstract classes, which I have shown in italics.